Hello everyone, and today we're going to be talking about the solar system, which is in many ways our backyard in space. So, at the center of the solar system is the Sun, and the solar system was formed around the Sun as a star when it was first born. This happened around 4.6 billion years ago, and the Latin word for sun is sol, and that's where we get the word solar. It means to do with the sun. So the sun is 99.8% of all the mass in the solar system. So you might think Earth is pretty big, you might think Jupiter is pretty big, but compared to the sun, we are all effectively nothing. The mass of the sun is 1.99 times 10 to the 30 kilograms, and when you get into standard form, it's the size of the number by the 10 that really matters, and 10 to the 30 is much bigger than any number we've looked at so far. So the wanderers, these are the planets. 8 planets orbit the sun. Planet comes from the Greek word for wanderer. This is because they used to be stars that wandered across the sky. They moved each night, and this was strange to the ancients. So there are 2 types of planet, the way we describe the solar system. There's the inner terrestrial planets, and these are small and rocky and solid. And then there's the outer giant planets, which are made mostly of lighter elements. Sometimes called the gas giants. So, how far is really far? What are we talking about here? Well, the distances involved in cosmology are big. And when we're talking about distances in the solar system, this really is just an introduction to the absolutely incredible distances that you deal with in cosmology. So yes, no matter how big you think really big is, the distances involved in cosmology are bigger. So we need a special way to talk about these distances, and the distance from Earth to the Sun is an average of around 150 million kilometers, and we call this value an astronomical unit, or AU. So we have other distances, other units for larger distances, and these could be, for example, the light year or even the parsec. And a parsec is a strange unit we probably won't deal with, but a light year is something that we'll come to understand in due course. So we'll start off by looking at the inner planets, and these will be shown approximately to scale with each other in the pictures. So Mercury is the closest planet to the Sun, and it has no moons. It's very small. You can see some information about it down there. Its mass is 3.3 times 10 to the 23, and you'll notice that the planets only go up from an order of 10 to the 23 kilograms to around 10 to the 25 kilograms. That's the range of masses that the planets have. The distance to the Sun is 0.387 AU, so 40% of the distance from Earth to the Sun then. And you'll notice that the length of day on Mercury is longer than a year because it rotates on its axis so slowly. So it also has no atmosphere, which means in the swing from day to night there's a massive change in temperature from 100 K at night, which is negative 170 something Celsius, to over 700 Kelvin during the day when it's facing the Sun. Mercury was named after a Roman messenger god, and the next planet was named after the god of love, and that's Venus. So Venus is a bit bigger. It's in the order of 10 to the 24 kilograms. It's 0.7 astronomical units from the Sun, and its length of year is much more similar to Earth's, but the length of day is also extremely long. It takes a very long time to rotate on its axis. Venus is only a little smaller than Earth. It has no moons also, and it has a thick carbon dioxide atmosphere, and this has created a runaway greenhouse effect, so the surface of Venus is incredibly hot. This was also thought to be caused by a lot of volcanic activity in its past. As we said as well, it's named after the Roman goddess of love. After that, of course, we have Earth. We all know Earth, and its mass, as we saw, is slightly bigger than Venus. The distance from the Sun is nice and easy to calculate. Earth is the only planet that is known to have life, in the universe that is. It has one moon, and we find ourselves in the so-called Goldilocks zone of the Sun. This is the area where life is most likely to arise, we think. So there's a symbol for one Earth mass that is used in cosmology, and it's a capital M with a small crossed circle, and that is the symbol for Earth. So this is often the case when you have a constant in cosmology. There's a capital letter with a subscript, and that subscript is sometimes a symbol. The last of the inner planets is Mars. It's a little bit smaller than Earth. In fact, it's more of the order of Mercury. It has a distinctive reddish-brown colour. It's called the red planet. There are two tiny moons, Phobos and Deimos, and indeed one of those moons has been now calculated to be breaking up and will soon be gone. When I say soon, I mean in tens of thousands of years or so. So Mars also has a carbon dioxide atmosphere, but it's much thinner than Venus, so Mars is actually very cold on the surface. Discovery of life is still possible on Mars. We've just recently made some new discoveries which have led us to believe that, and Mars is named after the Roman god of war. So now we move on to the outer planets, and these are also shown approximately to scale with each other, and the first and largest planet in the solar system is Jupiter, which has a mass of the order of 10 to the 27 kilograms. So it's the largest of the planets. It has 67 known moons, and both Jupiter and Saturn have no surface, and so gaseous hydrogen and helium become liquid and then we think finally solid deeper down, and this is why the length of day on Jupiter is so incredibly short. The surface of Jupiter, being only gas, can orbit much quicker than anything solid could do, and so the length of day on Jupiter is actually only 10 Earth hours. However, it takes much longer to go around the Sun at 11.9 years. And there's another feature of Jupiter which is well known, the red spot, a gigantic storm which has been raging for hundreds of years, but in astronomical time that's really not very long, and it seems like this storm might be coming to an end now, and that Jupiter in the future will no longer have this distinctive red spot. After Jupiter comes Saturn, a mass of the order of 10 to the 26 kilograms, and so again it's much further out than even Jupiter, so it has a much longer year but very, very short day. It's well known for its ring system, and the ring system is made of trillions of tiny moonlets, although we don't really count those. It has 62 known actual moons, and Saturn and also Jupiter may have a rocky core, we're not sure, and that rocky core is likely to be surrounded by metallic hydrogen under such great pressure that hydrogen has actually become a metal. So most of Saturn is thought to be liquid hydrogen. The other two outer planets are a little bit smaller. There's Uranus, which is of the order of 10 to the 25 kilograms. It's way out at 19 AU from the Sun. It still has a very short day, but of course it has an incredibly long year, 84 Earth years. So it's the first planet discovered with a telescope, and there are 27 known moons of Uranus. It's the only planet that spins on its side, so it seems to be almost rolling through space, but this is thought to be because it had some huge collision early in its formation that spun it round onto its side. So ice giants, which are what we call Uranus and Neptune, contain more ammonia and other complex chemicals than the gas giants, and Uranus is unusual in that it's named after a Greek and not a Roman god. And then finally we have Neptune, and Neptune's existence was actually predicted by mathematical analysis, and then it was discovered later by observation. It has 14 known moons, and it's denser than Uranus, so even though it's got a higher mass, it's now of the order of 10 to the 26 kilograms, it's actually slightly smaller than Uranus. It's named after the Roman god of the sea. There are smaller objects throughout the solar system. Many of the planets have moons, and there is also the well-known dwarf planet Pluto. There are also 2 rings of debris, and that's the asteroid belt between Mars and Jupiter, and then there's the Kuiper belt, which exists outside of Neptune and is actually where Pluto is, and one of the reasons why it's not actually thought of as a full planet. The rings of debris were failed planets, essentially. They failed to form, or perhaps they were destroyed early in the solar system's life, and the remains have spread out into a ring all the way around the Sun. And then far away from the Sun there is the Oort cloud, which is still just theoretical, but that's actually thought to be a sphere of comets, which are about 100 AU away from the Sun, going out to 10,000 AU from the Sun. So what are comets? Well, comets are icy, rocky mountains that have fallen into highly oval-shaped orbits, and so they come in towards the Sun and then they zoom out away from the Sun. They can have quite short or very, very long orbital periods of hundreds of years. Comets mostly come from the Kuiper belt and possibly from the Oort cloud. One of the most famous ones is Halley's Comet, which I remember back when I was a child. It's coming back in 2061. I might still be around for that. Some other interesting places that are found around the solar system include Pluto, of course, which is a dwarf planet in the Kuiper belt outside Neptune's orbit. It has not cleared its orbit, which is one of the reasons we don't call it a planet anymore. And it has 5 known moons, however, and the largest of these, Charon, has a diameter that's just over half of the diameter of Pluto itself. So it's really not much bigger than even some of its moons. There are many moons in the solar system bigger than Pluto. We have now brand new images of Pluto because the New Horizons probe passed it in 2015. Then there's Europa, one of the moons of Jupiter. It's one of the 4 Galilean moons, which means it was originally discovered by Galileo with one of the first telescopes. And it's believed that an ocean of liquid water exists under the icy surface, and this is possible because of the tidal forces that exist between Europa and Jupiter, and the gravity of Jupiter squeezes the inside of the moon while it orbits and rotates, and this leads to ice being able to melt into liquid water. In fact, Europa has been thought of as one of the best chances we have to find real life elsewhere in the solar system. So one other interesting place is Mars again. There has been a lot of renewed interest in Mars in recent years. We were not interested in it for a long time, but now we've sent more probes and we've discovered interesting things like liquid water that runs beneath the surface of Mars even now. So there's now a much higher chance of life than we thought, although this life is likely to be microbial life, very simple life. However, that means we are increasingly talking about colonizing Mars, going and living on Mars. But if we were to find life on Mars, what would be the effect of this colonization? Should we terraform the planet Mars so that we can live there? And what would happen to the life that is there if we did? So there are things we're still not quite sure about the solar system. The Oort cloud I mentioned before is a hypothesized cloud of comets. Technically, we've not yet proved the cloud exists, but it does explain many of our observations. It's a huge spherical cloud of icy objects that starts at 1,000 AU, not 100, and goes out to 100,000 AU. So I was an order of 10 out with my estimates before. So many long period comets are thought to come from the Oort cloud, and this is why they have such long orbital periods. So as with the asteroid belt and the Kuiper belt, the Oort cloud is the remains of material from the solar system's formation, but for various reasons it's formed into a spherical shape rather than a disk. It is also possible that we might find another planet. It is conceivable that we could find another planet in the solar system out beyond Neptune and beyond the Kuiper belt. Some of the comets suggest maybe a large object is orbiting the Sun at around 250 AU. There is other evidence about a planet possibly at around 200 AU, but this is all still stuff that we are not sure about. In 2014, two teams of astronomers spotted something moving on their images, but they haven't managed to confirm anything at this time. Other astronomers are skeptical, and there has been nothing peer-reviewed so far. So finally, we have a schematic diagram of the solar system here from above and not to scale, so be clear about that. So inside we have the Sun, the yellow circle in the middle, and then the terrestrial planets are found next, and outside Mars is the asteroid belt, the first of the ring of debris, and then there is a giant planet area where you find Jupiter and Saturn and Uranus and Neptune. Then your Kuiper belt, where you will also find Pluto, and outside that is an area we didn't talk about, the scattered disk. So this is like the Kuiper belt, but it goes out much further, and it's just similarly full of rocky objects. And then finally, at a much further distance than this diagram shows, the Oort cloud, which is spherical. And so aside from the Oort cloud, everything else in the solar system is roughly found on one flat plane.